Hi everyone, I'm Satsara Prahashana from Design Group 12 and I'm excited to present the smart light system with web-based remote control and automation. This project is all about making lighting smarter, more energy efficient and easier to control, whether you are at home or halfway across the world. Today, I'll walk you through the project's goals, how it works, its key features, and what's next for this system. Let's get started. Before we dive into the goals, let's quickly understand the problem we are addressing. In many outdoor spaces like porches, corridors, gardens, and entrance areas, lights are often left on unnecessarily, especially when they are manually operated. This not only wastes electricity but also leads to higher utility bills. Additionally, traditional lighting systems in these areas rarely offer remote control. Our smart light system addresses this by automating lighting based on natural ambient light using an LDR sensor, providing manual override when needed, and enabling remote control through a secure web interface. It's a solution designed to save energy and add smart functionality to outdoor and semi-outdoor lighting setups. The smart light system was designed with three main goals. The first one is energy saving automation. Using a light sensor, the system automatically adjusts lighting based on ambient light levels, ensuring lights are only on when needed to save energy. The second one is user-friendly remote control. A web interface lets you to monitor and control the system from any device, anywhere using secure remote access. The final one is power usage insights. Real-time power monitoring helps users to track their electricity consumption, encouraging smarter energy habits. These objectives make the system both convenient and eco-friendly. Let's look at how the system is built. At its core is the ESP32 microcontroller, which handles processing and Wi-Fi connectivity. A light dependent resistor or LDR senses ambient light levels, while a relay module controls the light's on or off state. A rocker switch provides manual control for convenience, and an ACS712 sensor tracks power usage. The web interface, built with HTML and JavaScript, is hosted on the ESP32 and made accessible remotely. The setup ensures seamless integration of hardware and software for a smooth user experience. The system shines through its four key features. The first feature is manual mode. A physical rocker switch lets you to control the lights directly when you are nearby. This is great for quick, no-fuss operation without needing to open the web interface. The second feature is auto mode with real-time status. In auto mode, the LDR sensor turns the light on or off based on ambient light, saving energy automatically. The web interface shows the light's status in real time, so you always know whether it's on or off. The third feature is remote access and responsive interface. You can control the system from anywhere using web interface, which works smoothly on phones, tablets, or computers. NG-ROC ensures secure access so you can manage your lighting even when you are away. The fourth feature is power consumption monitoring. The system displays real-time energy usage, helping you to track and reduce electricity consumption. which can lower bills and support eco-conscious choices. These features make the system versatile, user-friendly, and energy efficient. You will see these features in action in a separate video demonstration where we showcase the system's real-world performance. Now, let's talk about the tools and technologies behind the system. We programmed it in C++ using the Arduino IDE for efficient control of ESP32. The web interface was built with HTML and JavaScript, ensuring a smoother user experience. For remote access, we used ng-rock and local Wi-Fi to provide secure connectivity from anywhere. The hardware includes the ESP32 microcontroller, an LDR module, a relay module, ACS712 for power monitoring, plus an LCD. Together, these tools create a fully functional smart lighting system that's both powerful and accessible. You might wonder why we include a manual switch and skipped a motion sensor. The switch gives user direct control when they are close to the light, making it practical for everyday use. Motion sensors, while considered, can be triggered by animals or other movements, causing unnecessary light activation. The LDR sensor is more reliable, activating lights only when it's dark, which saves energy more effectively. In summary, the smart light system combines automation, remote control, and energy monitoring to create convenient and sustainable lighting solution. It's easy to use, saves energy, and works from anywhere. Looking ahead, we could enhance it with a mobile app, push notifications, or integrate with smart home systems like Alexa. I invite you to check the demo video to see it in action. Thank you. I'm happy to take any questions.
Hello everyone, this is our smart light system. First to the manual mode. Here I am using the rocker switch to turn the lights on, and now it's off. Then to control it from the website, we have to log into our website, and this is our home page. Here in the manual mode, we can turn the lights on and off. Now let's move on to the auto mode. Here the LDR detects ambient lights, and when it's dark, the lights turns on. Now to the power monitoring. Here's the real-time energy usage of the light. This helps me to track and reduce electricity consumption, saving money and supporting sustainability. And here you can see the toggling history, Wi-Fi status, light status, whether it's turned on or off, whether it's on auto mode or manual mode. You can see power consumption and the active time. That's the smart light system, combining automation, remote control, and energy monitoring for smarter lighting. Thanks for watching. Hi everyone, I am Satsara Praharsana from Design Group 12. Welcome to the demonstration of our smart light project. First, let's use this rocker switch to turn on the lights and off. Now, let's move on to our website. This is the home page, and right here in the manual mode we can turn on the lights on and off using these buttons. Now let's switch on to the auto mode. Here this LDR module detects ambient light, and when it gets dark the lights turn on. Right. Now let's move back to our website. Here you can see the power monitoring chart, and right here you can see the toggling history, the times that the light was turned on and off. Here the Wi-Fi status, whether it is connected or not, light status, whether it is on or off, whether it is on manual mode or in auto mode, and the power consumption and activation time. Now let's see what are the components of this smart light system. We have used a power supply, a LDR module, a rocker switch, LCD display, buck converters, ESP32 microcontroller, and relay module. This is the LDR module. This detects ambient light, and this one is the rocker switch. This helps to turn on and off the lights. This is the LCD display, which displays the LDR value, power consumption, energy consumption, and finally the lights on or off state. This is the light on, and this one is the power supply, which gives an output of 12 volt of DC current. Now let's see the inside of this circuit. Right here we have two buck converters, which helps to convert voltage. Each buck converter takes an input of 12 volt, and this buck converter gives an output of 5 volts to trigger this relay module, and this buck converter gives an output of 3.3 volts to activate the microcontroller. And this is the ACS712 module, which helps to track the power consumption of the light. And finally, this is the main component of this circuit. This one is the ESP32 microcontroller. This is the component that controls all the other components of this circuit. We have uploaded the Arduino code to this component. These are the all components of this circuit. Thank you for watching.